Hello guys, welcome. Wait. Welcome to Ashito's coaching channel. Today we are going to start a chapter name is इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस। होता क्या है देखो, जानते हैं। The energy point of a view can be used in electricity and is especially useful. Okay, energy is also a tool in solving the problems and more easily in the many cases than by the using force and electric fields. Energy can be stored in a common device called capacitor, which found in nearly all electronic circuit, and the capacitor is used as a storehouse for the energy, and the capacitor are stored the energy in the common photo flash unit. And the electrostatic potential क्या होता है? Electrostatic potential V at any point in electric field is equal to the amount of work done in per unit positive test charge, or the bringing unit positive test charge from the infinite to that point against the electrostatic force without the acceleration. V is equal to W by Q. Electric potential difference क्या होता है? Electric potential difference is a work done by the external force in bringing a unit positive charge from a R point, okay, from R to point P. Vp minus Vr is equal to Vp minus Ur by Q. Here Vp and Vr are the electrostatic potential at P and R respectively, and Up and U are the potential energies of a charge Q when it is at P and R respectively. It is not actual value of the potential but the potential difference that is physically significant. We choose the potential to be zero at infinity. The above equation implies. Now unit for the electric potential. The unit of measurement for electric potential is the volt, and so the electric potential of is often called the voltage. A potential of 1 volt V and equal 1 joule J of the energy per 1 coulomb C of the charge. 1 V is equal to 1 J by C. Okay, यानी कि 1 volt is equal to 1 joule per coulomb. Potential due to a point charge. Consider a point charge Q placed at a point O, considered at any point P in the field of the above charge. Let us calculate the potential at point P due to the charge Q and kept in point O. Since the work done is independent of the path and we choose a convenient path along the radial direction, let the distance OP is equal to R. Electric force at P due to Q will be directed along OP given by. If the work done by the moving charge, if the work done by the moving this positive charge due to doctor distance, okay, so dr distance is W, and then hence the total work done is bringing this charge from the infinity to R will be, and hence the from V is equal to W by Q naught, and electric potential is this energy is true for any sign of charge where for Q less than 0, V less than 0, that is work done by the external force per unit positive charge to bring it from the infinity to the point is negative. Also the equation is consistent with the choice that the potential is infinity be 0. Okay, potential at infinity be 0. अब जानते हैं पोटेंशियल ड्यू टू एन इलेक्ट्रिक डाइपोल क्या होता है. कंसीडर डाइपोल ऑफ लेंथ 2a and let P be a point at a distance from R1 and from Q positive and Q negative. Let R is the distance of P from the center O of the dipole. Let theta be an angle between the dipole and the line OP. इको पोटेंशियल क्या होता है देखो. इको पोटेंशियल सरफेस इज द सरफेस with a constant value of the potential at all point of the on the surface. For a single charge Q, the potential is given by. This shows that V is a constant if R is a constant. Okay. Thus, equipotential surface of a single point charge are the concentric spheric surface and the centered at the point charge. Okay, example कहा जाए तो फर्स्ट देखो सरफेस ऑफ अ गुड चार्ज कंडक्टर, और देखा जाए तो ऑल पॉइंट कोडिस्टेंट फ्रॉम द पॉइंट चार्ज, ओके, इक्वल डिस्टेंस फ्रॉम द पॉइंट चार्ज, ओके। नाउ देखा जाए तो कुछ इसमें नोट की बात आती है, जैसे कि देखो an equipotential surface is that at which every point is at the same potential as the work done is given by Va minus Vb into Q naught. First second देखो work done by the electric field while a charge moves on a equipotential surface is as 0, Va is equal to Vb. अब देखो relation between the electric field and the potential gradient. The negative sign in the expression signifies that as one moves in the direction of the electric field, potential differences decreases. Potential energy of a system of charges. First, a potential energy for a system of a two-point charge. The potential energy of a system of two charges is defined as the work done in assembling this system of the charges at the given position from the infinite separation. Consider two charges q1 and q2 separated by the distance r. Imagine q1 to be uh, and q2 it at infinity. The electric potential at B due to the charge q1 is given by, which is the work done in bringing unit positive charge from infinity to the B. Therefore, the work done is bringing charge q2 from the infinity to B is W is equal to work potential differences into charge. The work done is the stored as a potential, hence the potential energy between the charges q1 and q2. Potential charges of a system of more than two charges. Let us find the potential of a system of three charges q1, q2 and q3 at the position r12, r23, r3 and r31 respectively. The electric potential energy of this system is the sum of the potential of each other, hence we can write. Third, potential energy of a dipole in an external field. Consider a dipole of the dipole moment P suspended in a uniform electric field of the intensity E. Let theta be the angle between the P and E. Then the torque tau is equal to Pe sin theta. Let the dipole be turned through the angle d theta. Then work done. dw is equal to tau d theta. dw is equal to Pe sin d theta, and the work done in the rotating the dipole from the theta 1 to theta 2. तो यहाँ पे हो जाएगा W इज इक्वल टू पी ई कॉस थीटा वन माइनस कॉस थीटा टू, यानी कि फर्स्ट एंगल माइनस सेकेंड एंगल. द वर्क डन इज स्टोर्ड एज पोटेंशियल एनर्जी, ओके. अब देखा जाए इलेक्ट्रोस्टैटिक कंडक्टर क्या होता है, तो सीधी बात ये है, द कंडक्टर कंटेन मोबाइल चार्ज कैरियर इन मेटेलिक कंडक्टर. दीज चार्जेस कैरियर्स आर द इलेक्ट्रॉन्स इन मेटल्स आउटर valence and outer valence electron part away from their atoms are free to move. These electrons are free within the metal but not free to leave the metal. Whenever a conductor is placed in an external circuit field, the free electrons in it experience a force due to it and start moving opposite in the field, and this movement makes one side of the conductor positively charged and the others negatively charged. This created this creates an electric field in the conductor is in in a direction opposite to the external electric field called the nucleic induced field, okay. उसके बाद देखा जाए important point about the electrostatic of conductor. First है inside a conductor an electrostatic field is zero. When there is no electric current inside or the surface of a conductor, the electric field inside the conductor is anywhere zero. At the surface of a charged conductor, the electrostatic must be normal to the surface at any point. If field E is not normal to the surface, it will have a non-zero component along the surface. Hence, the free charge on the surface will move due to the electrostatic force, but free charges on the surface in electrostatic remains at the rest. So the electrostatic field at the surface of a charged conductor must be normal to the first surface. The interior of a conductor can have no excess charge in the static friction, okay, static situation. अब उसका जाता है इलेक्ट्रोस्टैटिक shielding क्या होता है in electrostatic situation. If a conductor contain cavity and if no charge is present inside the cavity, there can be no net charge anywhere on the surface of the cavity. This means that if you inside a charge conducting box, you can safely touch at any point on the side wall of the box without being electrocuted, okay, and this is known as the electrostatic shielding. तो इलेक्ट्रोस्टैटिक शील्डिंग में कोई दिक्कत था नहीं. अब देखो आगे जानते हैं हम लोग. अब यहाँ आता है डाई इलेक्ट्रिक एंड द पोलराइजेशन क्या होता है. डाई इलेक्ट्रिक आर नॉन कंडक्टिंग सब्सटेंस इन कॉन्ट्रास्ट टू द कंडक्टर and they have no and or no or no, negligible number of charge carrier. When a conductor is placed in an external electric field, the free charge carrier move and the charge distribution in the conductor adjusts itself and in such a way that the electric field and due to the induced charge oppose and the external field within the conductor. This is happened until and in the static situation the two fields cancel to each other and okay, the two field cancel to each other. Now हाँ, कैंसल टू ईच अदर, ओके, यहाँ तक तो हमने पढ़ लिया था. नाउ वेट. Cancel together and the net electrostatic field in the conductor is zero. When a dielectric material is kept in an electric field, the external field induces a dipole moment by the stretching or reorienting molecules of the dielectric. This results in the development of net charge on the surface of the dielectric, which produces a field at that the opposed the external field. Dielectric can be classified into polar and non-polar dielectric. If non-polar molecules, the center of positive and the negative charges coincide, molecules thus has no permanent dipole, and the example of non-polar molecules are oxygen, O2 and H2 molecules with which because of the symmetry and have no dipole moment. Okay, तो हाइड्रोजन जो होता है उसको ध्यान रखना कि वो नॉन पोलर में आता है. The polar is one in which the center of positive and negative charges are separated even or where is no external field and such molecules have permanent dipole and इसका फोटो ले लो. And molecules such as HCl or molecules water H2O are the example of polar molecules. Behavior of a non-polar dielectric क्या होता है. In an external electric field, the positive and the negative charges of non-polar molecules are displaced in the opposite direction. The displacement stops when the external force on the constituent charge or of the molecules is balanced by the restoring force. The non-polar molecules thus develop in and induced dipole moment, and the electric and the dielectric is said to be polarized by the external field. Behavior of polar dielectric. Dielectric with the polar molecules also develop in a net dipole moment in an external field, and but for a different reason. In the absence of an external field and the different permanent dipole moment are oriented by the randomly due to the thermal aggregation, and so the total dipole moment is zero, and when an external field is applied the individual dipole moment and the tend align the with the field. The capacitor क्या होता है. The capacitor is a system of two conductors separated by the insulator. If the two conductors have have a potential difference between them, as any potential difference is able to the accelerate charge and the systems effectively stored energy. Such a device that can maintain the potential differences and storing energy by the storing charge is called the capacitor. When the charge q plus and the q minus is given at the two plates, a potential charge develops between the two plates. The capacitance of the arrangement of is defined as the c is equal to q by v. Okay, अब देखो कैपेसिटेंस क्या होता है. Capacitor is defined as the amount of charge required to raise and the potential of a conductor by 1 volt. The capacity of an isolated sphere conductor. The consider a sphere and with a center O and with radius r, which is supplied with a positive charge, and the positive q, and this charge is distributed uniformly over the outer surface of the sphere. Thus, the potential at every point on the surface is the same and is given by the C is equal to 4 pi E naught R. उसके बाद पैरेलल प्लेट कैपेसिटर. द अरेंजमेंट कंसिस्ट ऑफ टू थिन conducting plate, each of area A and separated by a small distance d. When a charge q is given to the first plate and a charge minus q and is induced on the inner surface of the other plate and the positive of the outer face of the plates, as this face is connected to the earth, the a net negative charges is left on the side on this plate. Thus, the arrangement of equivalent of two thin sheets of the charge, as d is much smaller, the linear dimension of the plates d2 is less than a, and we can कह सकते हो a जो बहुत बड़ा होगा d2 से, and we can use the result of electric field by an infinite sheet of the charges, and the electric field between the plate is for uniform field potential difference between the plates. ओके, उसके बाद देखो कहा गया है इन इफेक्ट ऑफ द डाइलेक्ट्रिक ऑन द कैपेसिटेंट. व्हेन अ डाइलेक्ट्रिक स्लैब और डाइलेक्ट्रिक कांस्टेंट is k is inserted between them plates and the filling the entire spaces between them, the plate of the capacitor are given charges positive q plus and negative q. Hence induce image charges o minus qq minus qp and plus qp appear on the surface of the slab. So the capacitance increased to the k times, and when the spaces between the plates is filled with a dielectric order of the dielectric constant k. उसके देते कॉम्बिनेशन ऑफ कैपेसिटर क्या होता है. इसमें होता है सीरीज ग्रुपिंग. द अरेंजमेंट शोन इन द फिगर आर द एग्जांपल ऑफ सीरीज ग्रुपिंग व्हेन द कैपेसिटर कैन बी अरेंज्ड इन अ रॉ and so there is no connection between the capacitor to any third capacitor. It is called the series combination, or when the same charges flow at each other through each capacitor connected. Okay, and the parallel grouping में होता क्या देखो. The arrangements shown in the figure are the example of parallel combination when the two or more capacitors are connected between them and the two given point they are said to be in parallel, or when the capacitor bears the same potential difference across it. Energy stored in capacitor क्या होता है. ओके, तो जान लेते हैं. During the charging a capacitor, work has to be done and add a charge to the capacitor against its potential. The work is stored in the capacitor as electrical energy. Suppose during the charging of the capacitor, its potential at any instant is given by the V is equal to Q by C, and a small amount of work done is adding a charge. dq is given by dw is equal to q by c dq. The total work done is giving a charge q is, and to the condenser q is equal, u is equal to half qb. Okay, thanks for the so guys, thanks for watching video till the end, and don't forget that you are a part of journey of neet, so don't forget to like, share and subscribe. Bye, and see you in next video.